Welcome to section 15.7, complex numbers, also known as imaginary numbers. So, in the previous chapter, I talked about where we can only find square roots of positive number. And the reason is because when you find square roots of positive numbers, you get real solution. Now, when it comes to working with square roots of negative numbers, those are called imaginary numbers because they're not real solution. So the difference between real and imagine, or imaginary numbers, is that the real numbers, you can do the square root of positive numbers, whereas imaginary numbers, such as imaginary world, are the square root of negative numbers. So you can connect where imaginary numbers is like imaginary land. It's not real, but it does exist in the complex world, in the complex field. So here, you're gonna hear me referring complex number, also known as imaginary numbers, and we usually associate square root of negative numbers, mainly square root of -1, with I. Now on the left side, I list out the 4 types of imaginary numbers. The first one is I to the 1 power, where it's equal to square root of -1. So where you see a square root of -1 is equivalent to I, and vice versa. Where you see I, it's equivalent to square root of -1. The second is I squared. That is equal to -1. I to the 3rd power is equal to -I, and I to the 4th power is equal to +1. So here we're going to be using these 4 types for complex numbers to work on some examples, such as right here, if it asks you to find a power of I. So how will we simplify I to the 7th power? So this is our first example. What you're going to do is, the basic step is list it out. So if it's I to the 7th power, that basically means I times itself 7 times. Now, as you can see, I wrote the I 7 times. Now, there's one thing we do know, is that I to the 4th basically means I times itself 4 times. So, right here, I to the 4th power, this is the same thing as I to the 4th power, which is basically 1. Whereas the remaining i's that we have, I times I times I, that is just basically I to the 3rd power, and I to the 3rd power is -I. So here, basically I to the 4th times I to the 3rd is I to the 7th. And then when you simplify I to the 4th, it's just 1 times I to the 3rd, which is equivalent to -I. So 1 times -I is -I. So I to the 7th is -I. And let me box that up. Now, when you expand, like how I did when I wrote out 7 i's, you can clearly see the final answer for I to the 7th, which is -I. But the issue is that it's tedious when you're expanding, especially when you have a high exponent. So I'm going to show you another method, which is a shortcut, an easier way when you're working with higher exponents, because of course with low exponents you can expand and clearly see. But imagine doing I to the 117th power. There's no way you're going to write out i's 117 times and then just count by 4, because that's what I did here. You do that, that's very tedious. I mean, that's the basic way, but that's very tedious. So I'm going to show you another method. So for I to the 7th power, we're mainly going to work with I to the 4th. So what I'm going to do is I'm going to divide the exponent, which is 7. I'm going to divide by 4. So I'm going to do long division for the number. 4 going to 7 one time. Subtract, I'm left with 3. So I'm going to rewrite I to the 7th power as I to the 4th to the power of 1 times my remaining, which is I to the 3rd. The 1 is from here. And then now you can rewrite I to the 4th as 1 to the 1 power times I to the 3rd. 1 to the 1 power is just 1, and then times I to the 3rd, which is I to the 3rd. And then you can still simplify because I to the 3rd is negative I. Now you don't necessarily have to write out all the steps as like I did, but I was just writing step by step. And then this is our final answer. Here we have I to the 50th power. So what I'm going to do is do the long division with the exponent. So 50 over 4, so long division, like so. 4 can go into 5 one time. I'm going to subtract 10. 10 can go into, 4 can go into 10 2 times, which is 8. Subtract, my remainder is 2. So I'm going to use my remainder. I'm going to rewrite I to the 50th power with I to the 4th. Raise it to the power I have here, which is 12, times I with my remainder, which is 2. Now I to the 4th, we know that that is just 1. Raised to the 12th power times I squared. Now 1 to the 12th power is just basically 1. And then here, we know that I squared, based on this information, is negative 1. So here you can just work it out. 1 times negative 1 is 1. There you go. Our final answer. Now here I just did it quicker than the last example. In the last example I was doing step by step. But here I just went straight from I to the 4th to 1. Raised it to the 12th power, which is 1. And then here convert I squared to its equivalent form, which is negative 1. And I just did 1 times negative 1, negative 1. In this example, we have I to the power of 125. So again, I mentioned how it's very tedious if you were to write the i's out 125 times, which is, again, too much work. So I'm going to work with the exponent, 125 divided by 4. So we're going to do this long division way. Four can't go into 1, so I'm going to use a 1 with the 2, making it 12. 4 can go into 12 3 times. When I subtract, the 12 cancel out, so I'm going to bring down to 5. Next, we're going to say 4 can go into 5 one time. So 1 times 4 is 4. Subtract, my remainder is 1. So now I'm going to rewrite I to the 120th power as I to the 4th to the power of 31 times I with my remainder to the 1 power. Again, we know that I to the 4th is just 1. raising it to the 31st power. And here again, I'm multiplying by I to the 1 power. 1 to the 31 power, or 31st power, is just 1. And then I to the 1 power is just this first one right here, the square root of negative 1. Now I'm not actually going to write out the square root of negative 1, it's just going to write as I. 1 times I is I. And that's all you have to do. This is my final answer. Now, quick review. When you're trying to find the power of I and you're working where it's I to the 1 power, you just basically going to leave it in this form. Now I'm going to show you methods of using square root of negative 1 when we're simplifying square roots.